Did you ever try to upload something to S3? It's not too difficult. The code just looks kind of like this. In my situation, I was uploading from a Express endpoint, and you can see I just had an upload endpoint. I called s3.putObject, passed the bucket, what I wanted it to be called, and the body straight through as a stream. OK, it's not quite that simple. It doesn't actually return a promise. We can't await it, so we pass a callback. But almost, right? Only, even though the documentation for S3 says that this library accepts a stream, it doesn't actually accept a stream. It accepts only streams backed by file descriptors. And this stream was coming from an HTTP request. So, OK, we have to use the create multipart upload. OK, the resolution's a little changed. I'm not trying to make it smaller than it is. But anyway, it was supposed to cover from top to bottom of the screen. Anyway, it's still not quite as easy as it looks. There we go. Or not quite as easy as we originally thought. So create multipart upload. It's like more complicated. You have to start the upload. You upload one part at a time. Once you have all the data, you finish the multipart upload. But OK, it's not so bad, right? Only this isn't quite all of it, because there's no guarantee that excuse me, there's no guarantee that the, let's see, what's the next step? Right, so the next step is that there's no guarantee that the responses from uploading a part are going to come back in the same order as we sent them out. So we could potentially end up getting the part E tags in the wrong order. When we call complete multipart upload, we have to send them that parts array in the correct order, or else our whatever file we're uploading is going to have like a whole chunk of bytes in the wrong positions. OK, so we keep better track of those things. But we're done now, right? Only when the streaming request ends, there's no guarantee that just because the user has finished uploading bytes to us, that all of the bytes we're uploading to S3 are already there and we've gotten the responses back. So this part down at the bottom where we're saying complete multipart upload, we can't actually do that. Instead, what we have to do is every time we upload a part, in the response, we're going to check and say, is this the last part? Has the stream from the client ended, and this is the last part for which we still needed an E tag for the upload part? If that's the case, then we can complete the multipart upload. And this is done. But if something goes wrong halfway through, then those parts that we uploaded, we're still going to get charged for those, even though we don't have a finished object. So if an error occurs in any of these pieces, we're going to have to call abort multipart upload. And are we even there yet? No, we're not even there yet. OK, it's hard to read the code, right? So here's where we are in the story. So yeah, at this point, we have error handling. We have all the parts are uploaded, and we keep track of the E tags in the correct order. We're doing everything right. Whoa. My name is Brian Schiller. Welcome to Joyful APIs. A joyful API is a beautiful thing. It's lovely to work with. It's pleasant. It's well documented. But the documentation that's there, it's like, oh, that makes perfect sense. The interface here is exactly the way I wanted an interface to work for what I'm trying to accomplish. For example, uploading things to S3. This first thing, that's the way I want the interface to work. This last thing, I don't know. This is what I had to resort to in order to get things to work. On the road to this code, how many mistakes did I make? Like, there were several concurrency bugs that were tricky and difficult to suss out, but they might not have happened locally. So maybe I wait until production to find out about some of these bugs. Am I really doing error handling in all the cases? I'm not even sure, honestly. In talking about joyful APIs, it's useful to talk about some not so joyful APIs. And over the course of this talk, we're going to learn some guidelines for recognizing and creating joyful APIs. There are a bunch of code samples here. They're like, helpful evidence, but if you can't read them like you couldn't in this case, that's not so much the point. I'm not expecting anyone to be able to read that code on the screen. But if you're interested in what some of these code samples are, if you want to compare them, the slides are up on my website right now, brianschiller.com/joyfulapis. So the first guideline we have is to orient around use, not internals. And the case for this is a really classic, my example for this is a really classic example from the Python community. URLlib2 is the built-in Python standard library way of making an HTTP request. But there's a lot going on here. OK, so we create a request. That should be enough. Only we also need to create an HTTP password manager with default realm. And once we have it created, we can add a password. And we can then create an HTTP basic auth handler using that password manager. For some reason, we need to build an opener and then install it. Finally, we can call URL open on the request. There's really a lot going on here that I don't want to have to care about. Yeah, I do want to pass a username and password. Whoops, forgot to turn off the clip events. But I don't want to think about their internal class structure. It's great and all that they have separation of concerns and they've decomposed their classes into small units that are easily testable. But when I'm trying to use the library, I want an interface that makes the things I'm trying to do easy. I want to orient around the way I want an API oriented around the way I'm using it, not internals. And so an example of a way to do this better is with requests. Requests is it's not part of the Python standard library. It's written by Kenneth Reitz. But you can see that there's nothing here that I don't want, is maybe the way that I want to put this. There's no piece here that feels superfluous or that feels like I'm only going through a dance to satisfy the way the library wants me to act. It's totally possible. In fact, I think it's the case that requests uses URLlib2 under the hood. But I don't want to have to think about that internal class structure. I want an API oriented around use, not internals. The second guideline is to move complexity downward. So my example for this is the virtual DOM. So this is another code sample that I don't expect anyone to read. But in the bad old days, before we had React and Vue and all of these fancy virtual DOM-based front-end libraries, if we wanted to do a real good job and have the most efficient DOM rendering possible, then let's say we have some list of data. In this case, it's dogs. And that data might have changed, so we need to do a re-render to the DOM. Well, we're going to need to see what's currently there, reorder the existing elements to match the current order. Sometimes the elements will already be in the correct order. Sometimes there will be a node that's already present in the DOM, but it's in the wrong location. And sometimes there will be a node that is newly created, and we need to do a document.createElement to add this new node and insert it into the correct spot. Once that's done, we need to go through and make sure that there are no nodes extra that we don't have represented in our model. So there's a lot of details. There's a lot of tricky DOM manipulation going on in this code segment. Actually, when I started to write this, I was surprised by just how difficult it was. It took me several tries to get this to where I thought it was really correct and doing the same thing as the next example. Right. The next example, which looks like this. This is the Vue version of that. Now, there's still a lot happening there, right? We've taken the complexity of creating new nodes, inserting them into the correct position. Sometimes the node already exists. We just need to move the node. And honestly, this is a simple example because I don't need to recursively render some subcomponent. I was just inserting li tags. But as a former coworker, David Cushman, says, something inevitably has to put shit in the DOM. So it's not that we have avoided, it's not that we're somehow like being more efficient and preventing these DOM changes. They're still happening. It's just that I don't have to think about them. Like when I'm thinking about showing a list of dogs, I don't have to also be thinking about, okay, so sometimes there will already be dogs in place, but not the same dogs. Some of them will overlap, and which DOM nodes need to get moved, and which ones need to get recreated, and when can I reuse a node for performance reasons? I don't want to think about all of that when I'm just writing an app. It's something the framework should handle. And so I'm arguing that the virtual DOM, and I'm a fan of Vue, but like substitute your favorite modern front-end framework in here. This is a way better user interface or programmer interface than direct DOM manipulation. A friend of mine likes to say that APIs are the user interface that programmers use. That's the way I like to think of them. Like when you're using a library, or just more like a concept like the virtual DOM, you're using some nice UI on top of some ugliness underneath. We want to move the complexity of DOM manipulation down below some layer to where we don't have to think of it anymore. That doesn't always work out. Sometimes there are cases where your abstraction layer that we've applied does the wrong thing. I remember I intended to put this in the slides and didn't have time today, but a student of mine was working on a project where he was showing like a loading indicator. He was using a GIF. I'm going to get so much heat for this. A GIF or a GIF, choose your poison. And he was using a GIF or a GIF as a loading indicator. And then what was loading was actually another GIF or GIF from like the Giphy or Jiffy API. And he was really confused because what was it that turned out happening? So the loading indicator is like spinning, and then the GIF shows up, and for a second it keeps spinning or something like that. I wish I had the example in front of me so I could demo it. But what was happening was that the virtual DOM was actually working against him. The view was reusing the same image tag, so when he replaced the source of the image tag, it didn't yet have the bytes for that image loaded, and so it was still using the little spinner that he had until those bytes came back. So it was behaving the way he didn't expect it to, and he needed to know a little bit more about the internals of how, it's replacing that image tag, and the way you avoid that is by saying, this is a key that represents the loader, and there's another image that I want you to create a new element for that represents the actual data. Still, even in the face of that, this is a way better API or UI for programmers. The next way that we can make joyful APIs is by suffering for your API. And this one is controversial. I remember when I gave this talk at the speaker workshop a couple weeks ago, and what I heard back was Kyle, one of the organizers of the conference, was like, and that's a bad thing, right? And I was like, no. You want pre-suffered APIs. If you pre-suffer your APIs, then your users don't have to suffer. Instead, you make all the hard decisions up front, like do all the tricky DOM manipulation in your code, and then it doesn't have to bleed into everyone's code. Like think back on that S3 example, where if the Amazon developers had like been a little bit more willing to suffer for their API, then there wouldn't be 500 different crappy implementations of the same code that I put up on the screen, all with like a couple bugs, a little bit different. They could have just made an API where they had already done all the difficult work. They'd already suffered for their API. So an example that I like for this is the JWT.NET library. And this example of code is straight out of their README. And you'll notice that They're creating a JSON-net serializer and a UTC datetime provider and a new JWT validator using that serializer and that provider. And then a base64 URL encoder. And finally, a JWT encoder passing in the serializer, the validator, the URL encoder. And this is all great because they've separated their concerns. Again, this is also related to orienting around use and not internals. But I'm sure this is like a great way to design their internal code. It allows them to test things. It allows you to try out like what happens if I try to validate a JWT way in the future, and you can just substitute out the UTC datetime provider to test different scenarios there. But oh, I thought I had something else coming. Oh, here it is. But I don't care. Like, I don't want to have to care about all of that as basically the client, as the user of their API. I should not have to care. And so here's a reimagining of what their API could look like. By, if they suffer for their API, choose reasonable default values that are going to work for most cases. They could have a JWT decoder that doesn't need any parameters because there's defaults. The other thing that I want to point out is missing. Back on this first page, we had a verify true option. When do you ever not want to verify your JSON web tokens? Let's make that the default, and you can turn it off if you need to. And you'll have not just an easier to use library, but a more secure one. Actually, I would take it a step farther. Let's just make it a static method. There's no reason I don't want to have to create an instance of your library to call decode. Yeah, the OO people might disagree with me on that, but this is what I imagine to be a much better user interface than this one. It's also a good plan to make common things easy. This is the next guideline. I use a library called Pulp for doing linear programming problems. Linear programming is like a really fun thing I'd love to talk about later. But to boil it down, what you do is you set up constraints. And instead of trying to directly solve a problem, the code has like a constraint solver that spits out an answer for you at the end. And there's a lot of ways you can apply this. I think it can make difficult problems into like much more easily accomplished things. You can just throw computer power at it. We have constraint solvers. Can we think of some constraints? A really common constraint is that two variables, especially like Boolean variables, you might want to compute the and of two variables. And when I needed to do this for a program that I was writing, I went on Stack Overflow and I was like, Boolean, what was it? Binary integer linear programming and compute and of two binary integer linear programming variables. And there was an excellent Stack Overflow answer that detailed exactly what I need and talked about the theory behind it. And I came up with these three constraints. That if you're trying to create an x and y, that will always take on the logical value of x and y. You need these three constraints. X and y must be greater than or equal to x plus y minus 1. X and y must be less than or equal to x. X and y must be less than or equal to y. And if we had more time here, I would pause and we could think through to ourselves all the different cases. We could pull up a truth table, and we could convince ourselves that, yes, those are the three constraints that we need in order to ensure that the x and y value is constrained to the logical value of x and y. But that's a really common need. What if instead you could just use it? What if that was a built-in function of the library? Let's make that common thing be easy to do. I actually published a library that does basically that. It's called Citrus, which is a play on Pulp. You're welcome to check it out. It's pretty fun. OK, so what about that S3 API? Let's come back to that. We wanted to build something. We wanted to write something that looks like this. And instead, we got bogged down with concurrency issues and capturing E tags that come back from responses and multi-part uploads and error handling. What went wrong here? So in Amazon's defense, it is fault tolerant. If one of those parts that I'm uploading fails, then I could have logic in place to retry that. And that way I don't have to cancel a 500 gigabyte upload just because one piece might have failed. It's parallelizable. If I have all the parts in available, I can start uploading multiple at once, and the whole upload will complete more quickly. And it's a direct map to HTTP, which is not always a good thing, but in this case, the way they're going to be charging me is by the HTTP call, and so perhaps it makes sense that I want to be in control of the code that is going to end up resulting in a charge on my credit card. But on the other hand, I don't really care. I don't care about those things. I'm just trying to upload some data. And this is a really common use case that they should be handling better. So let's pick this code apart a little bit more. It's organized according to how it works. It's very oriented around the internals of creating a multi-part upload. Oh, you know what I forgot to mention? I remember. That's how I got off track at the beginning. This is fun, though. Multi-part uploads, each part can be no smaller than 5 megabytes. So I have to buffer the incoming data until I get to 5 megabytes, and then I can send up a 5 megabyte chunk. So just lots of hairiness. And that's organized according to how it works. There's no reason Amazon's library for doing S3 uploads in JavaScript couldn't handle that for me. They left all the complexity for me to deal with. Where choices about what to do in the case of error handling, or all these concurrency issues. They're just going to say, we're not going to do the work. The user is going to have to deal with that. Meaning, this is like in programming, you always talk about, if you can save your users 1 second and you have 1 million of them, that's a lot of seconds. It adds up. And they didn't spend the time to make their library easy enough to use to avoid me spending, I think this was a full day and a half, figuring all of these problems out. It has roll your own error handling. I think I mentioned that one already. And the big thing is that a common use case ends up requiring a whole lot of code. So instead of that, let's orient around use and not internals. Let's move complexity downward, suffer for our APIs by choosing reasonable defaults and making hard choices about, well, I don't know what a reasonable buffer size is, but why don't I choose 5 megabytes, and then they can override that if necessary. That's the kind of hard choice I'm talking about, where you might not have data about it. And make common things easy. And above all, the best guideline I can offer you for building a good API is to imagine the interface you want to use, and then build that. And so if we follow these guidelines, and I'm sure there's more, I'd love to hear your thoughts afterwards, we can all work together and have more joyful APIs. Thank you.